Okay, we are going to bring to you a 3-part series, mainly due to the fact that we're seeing issues coming in our engineering office, our structural office, about foundation failures due to the installation of egress windows on existing foundation systems. So we're seeing enough problems with these installations that we felt it would be valuable to put together these series. And we've actually working on one home now that's complete structural failure due to a single egress. So it motivated us to do this. And of course, a lot of our videos are going to be foundation related, structure related, from the level engineering structural team. So, but I think that our first one's going to focus on demonstrating today is be just kind of simplifying and demonstrating foundation loading, what we need to worry about in regards to an egress window installation on an existing. Now, if you have an egress window in a new home, we're not talking about that. That was likely designed appropriately. It's this post installation of an egress window or enlarging a hole in a foundation on that existing condition. So a little bit about egress windows. We're going to use the box here for a little bit. You've seen that before in our videos. And then we're going to move away from this box, and we're going to make an attempt at a demonstration that's a little more real about the forces of lateral soil on your foundation wall. So let's talk about this a little bit. You likely have, so the box, your home foundation system being the sides, for simplicity, the sides of this is going to just be an example of the vertical walls of your foundation. We're simplifying again. So you may have a much more complicated home, but I think this will demonstrate it fine. The walls of your foundation, let's assume that's the sides of the box. The bottom of the box is your concrete floor, and the top of the box is your main floor system diaphragm. So in our foundation systems in residential, it's common and usual, especially in our older homes, that this system of a floor diaphragm, a basement slab, and the concrete or CMU walls creates this rigid structure for you to keep these walls from collapsing inward due to soil pressures on the outside. Now, you likely have, I'm just going to draw, this is might be if you go in your basement area, you might likely be looking at a smaller window or a group of smaller windows. What are these? The code still and always for many, many years has looked at these small windows as requirements. The requirement was and still is minimum light and ventilation for that uninhabitable basement space. Now that's a key word. So it's up to the owner or builder to tell our jurisdictions what the intent of the use is. And often in the past, it was uninhabitable space. The basement was used for storage. So the code reacts to that and goes, okay, you can put in these little windows and you just have a minimum requirement for light and ventilation of that uninhabitable space. Of course, now what's happening is, probably always happened, is we're finishing these basements. So the home got built, the building code was told, or the building official was told it's uninhabitable. Now we're finishing these spaces and the code changes. code requirement changes. If you put, especially in regards to a bedroom. So if your intention is to put a bedroom in your basement, make it habitable, no longer uninhabitable, you're going to actually live down there, the code changed. The code's going to make you say, okay, if you have a bedroom, you have to enlarge that window for emergency egress. The emergency egress issue is, when you read it, it seems odd, to be honest with you. It's got all these details about a minimum of 5.7 square feet, certain dimensions, a minimum dimension off the floor. It can't be more than 44 inches off the concrete floor, the bottom of the window, and 5.7 square feet, and it has operations. It's just a lot of detail. And the reason for that, the code has actually had that for a long time, but regarding a bedroom emergency egress, all those dimensions speak to a fireman with a tank, an air tank, having to go through this window and take an occupant, your kids or any occupant, and carry them out of this opening. So that's where all those sizes come into play. It's not just arbitrary. It's actually what it takes for a fireman to go in and save somebody from that bedroom from a fire. Again, a fire up here on the main floor, second floor, within minutes can trap occupants in the basement. This is their way out. So that's why that code's requiring it. Okay. So if you're going to occupy, the egress window is critical. I don't want to lose that in this conversation, but what this conversation's about, you made a decision, you want to put a bedroom down there. Egress windows are being installed all over the country right now. For many reasons, we're starting to occupy these spaces, but we're significantly modifying or adversely impacting the foundation structure. And that's what we're talking about here. So if you have, I'm just going to cut that small window in there. So let's say you have these small openings originally in your foundation. That small hole in your foundation wall has built in it often reinforcement that anticipated this small opening, and the structure's doing fine with that small hole, with that small window. And our contractor community is saying, well, our egress installation contractors are, what we're hearing often is, if we can put your new egress requirement, we can meet your new egress requirement by just not widening this opening, but just deepening it and not affecting the structure. And that's actually not true. So from a vertical standpoint, the low to the house, low to the floor, that type of thing, vertically, yes, you probably didn't adversely affect the vertical load, but you have significantly changed the ability of this wall to hold back the soil pressures. So if we went ahead, and when we do this in our other videos, we're actually going to show you an installation of these windows. And we're going to show you when a concrete saw makes these cuts in the foundation, you're actually most often cutting through the tensile reinforcement in our structure. And it's significantly destroying this structure from the lateral standpoint, the weight of the soil pushing this in. Now, in our other earlier videos and our other videos on YouTube, you can see that, and we'll show you this too, but what happens is the additional stress here due to that opening actually severs this connection because there's anchor bolts, and we'll show you that also in detail in our other videos, but there's anchor bolts that hold our floor system to the top of the concrete, and they're about every 4 to 6 feet along your foundation. It's just a 1/2 inch bolt every 4 to 6 feet, and that's not enough. And what happens is this opening has focused the stress, this load of soil on this 1 or 2 anchor bolts, and they can't resist it. And then this is what happens. And this is where we were seeing a lot of calls in our office. Very significant foundation failures happening because of these egress windows. We've lost a couple homes completely on this issue. Just really hundreds of thousands of dollars of damage because this was done to a home without proper replacement of structure or reinforcement of that new window opening. And that's what we're wanting to demonstrate in our next 3 videos. So I hope that makes sense. Vertically, yes, we didn't change the vertical load, but laterally, we've really compromised that structure. And that's what we're seeing is really causing problems. Now, we are having contractors getting really creative about saying, well, we'll build a frame, steel frame for our window, and that's all you need. And actually, that's not true either. A steel frame in just this opening does not prevent that rotation. The frame will just rotate and actually does not solve the problem. So, and we'll show you in our other videos how to brace these and how to do it correctly. Here's our ask and our recommendation as we go through these, is involve the structural engineer, your local structural engineer, and talk to your structural engineer about, hey, this is what I'm thinking about. Is it okay, or should I do something to reinforce it after I put in our egress? What I don't want you to do again is not put in the egress window if you have occupation. Please do the egress window. There's things we can do to reinforce that, but consult your structural engineer. We're gonna move on to another demonstration here, and I'm gonna try to convey this soil load against these walls and the weight. So if you have a 20, 30 foot wall, we're talking tens of thousands of pounds of load on your wall. If you're really a misbehaving person and you're not cleaning out your gutters, or you're left your hose on or whatever, and you're saturating these soils, we're going to demonstrate it here. You're saturating these soils, the weight of the soil, it can become a fluid, and that load against your home, especially if it's clay, can really get some tens of thousands of pounds pushing this wall over. And if you've done this, you may be in trouble. So we're going to do that. I'm going to mix up some concrete and sand, and we're going to move to a different demonstration model. Hopefully it works. I haven't tried it yet, and we're going to try to show this weight of saturation on a wall and how it behaves, especially the difference between and our little case model here about a large hole in your structure versus one that doesn't have that hole in it, and how they behave differently, and how it increases, again, the potential for foundation failure in your home. So let's move on to the next one. We're going to mix some concrete up. Thanks. All right, before we put our model in, there's an opportunity here to talk about loading of soils. This is sand, playing in the sandbox, obviously. But what the point I kind of want to demonstrate here, an opportunity to demonstrate here, is this issue of dry soils. So in a saturated soil turning into more of a fluid property. The fluid property against our foundation is our worst design criteria. That's the one we're worried about, is downspouts, gutters, poor drainage away from the home. Those kind of items can start getting our soil both heavy and at worst condition can start behaving like a fluid. So let me just kind of quickly, while I got this, where I'm just before we're putting our model in here, our demonstration of a foundation within soils. I'm talking about loading of these soils. Let me just show you this real quick. So this is a wet soil, obviously. Sandy soil is still wet. You might have clays and things, it's even worse, but look how that's standing vertically. So if we had a foundation here and your soils are drier or free draining, or you have an underdrain keeping things from getting too wet, that's good. You can see that if it stands vertically, there's not going to be a lot of load from this soil on your foundation pushing it over like that. But if it gets too saturated, what happens with these soils? Let me show you what happens when you have enough water. It doesn't stand up. It turns fluid. And that means your foundation has to support that supersaturated condition where our soils start acting like a fluid. So your foundation has to hold up that weight. And that's our worst case condition. See how that changes when you get enough water. I just wanted to show you that before we get our model in there. So let's get our model in there. So we're demonstrating what we've done is put obviously a Tupperware container just for demonstration. And this would be your basement. And here we had to weight it down because she started to float. Not surprising on our end, but that's why these are here, is just to hold Tupperware in. We completely saturated the soils, but for demonstration, this is if you were standing in your basement. This is the soil up against the wall in your basement. This is your outside yard. This is your outside yard flooded due to whatever causes, so your soils are saturated. And again, we're just demonstrating the difference between your, as I mentioned earlier, your minimum light and ventilation window. Same width as we cut over here, same location in the wall. But the difference in performance, obviously Tupperware is pretty consistent. This structure is the same as this structure, so that's why we picked it for demonstration purposes. So here's the deflection under saturated soil conditions. What is this Tupperware doing? And we're just going to show you that straight edge wise. For the most part, a little bit of deflection. Again, this is just demonstration, not that technical, overly simplified, but fairly straight still. And so what we did here is actually we filled it up, got both walls straight for demonstration, and simply added water. We didn't manipulate this. So this is actually, both sides were straight when we started, and we just added water. So now if we go to the other side of the wall where you put in your new egress window, you cut it lower. Again, code says 44 inches off the floor minimum. And we cut that larger hole in the structure. Same structure as here. And we're gonna notice the significance of the deflection in that wall, because we've removed so much structure here for this new egress window. The results are significantly different. So what we speak to, or what you may be hearing from egress window installers, being contractors or folks that are selling these products, is that structurally they didn't change anything. It's fine because it's the same width. And what we're trying to see demonstrate is actually the soil pressure, lateral pressures on your walls, you did significantly damage or interrupt your structure, your wall structure. Again, this can get up to tens of thousands of pounds when your soil is saturated. We're seeing numerous foundation failures coming in our office due to this egress window insulation. In worst cases, we've seen homes that completely destroyed for this. So hope that gives you a feel for kind of what we're talking about. We'll show you in episode 2 when you make that cut, demonstrating how much reinforcement are you cutting through, removing from this structure. Now, this is a structure holding soil pressure back, especially when it's saturated. It's a beaming effect. It will go like that under a load, and it can. Now we put a lot of stress right here in this maybe 1 or 2 anchor bolts. Those anchor bolts aren't going to hold all this pressure. They're going to fail, and so your floor system. If you look at the outside of your home, I'm going to put some pictures of this on this episode where the wall has left the floor diaphragm and is inset, failing inward due to lateral soil pressures. And we're going to show you what that looks like on the outside. Pay attention to that. We'll show you a couple of videos of that. And we typically see cracking in the corners. You see that on our previous videos about that cracking and how that works. But hope that gives you a feel for, hey, it's not okay to just simply take that existing window, cut it deeper because of your lateral soil problems. All right? We'll see you in the next episode.